And I do a liver cleanse every year. And I eat healthy. I eat mostly raw foods. Very little meat.
A heart attack and you needed immediate.
I won't get a heart attack. You know why? Because I stay away from sugar. Sugar is what scarifies the inside.
Oh, it's so great. I love sugar.
To be on the path.
I do have a legitimate question regarding the heart
Sugar
thing,
scarifies the inside of your circulatory system.
question.
And the cholesterol.
My mom was a cardiologist.
Because I studied. No.
You studied
I studied.
EMT, my mom's a PA, she was a cardiologist.
told you that sugar does that to your body.
I do have
Science told us.
This young man who has an association with medical things is asking a legitimate question about hearts.
I do
Okay, you have a question? Go ahead.
So, like I said earlier, obviously my family and I have a history in medicine. My question being, though, you can eat healthy all you want. You cannot avoid hereditary illnesses and ailments. So
That's where evolution comes into the picture.
I thought you said evolution
It isn't.
didn't exist.
That's right.
So what is?
It's 99.9. The only thing that's hereditary is RNA, and RNA can be changed. RNA can be changed.
Oh, like evolution?
Okay?
Ah, interesting.
No,
Evolution,
it's by.
For me,
Do you know what RNA is? Okay, there's DNA and there's RNA. It's inherited, but the RNA can be changed back.
Pretty sure.
Okay,
Don't you
to
they're
be
on your
healthy.
side. I think it seems like they're trying to just have a very here's a very mild conversation. You no need to attack anybody with that tone. But I'm just saying you still have yet to answer their question.
What is the question again?
They asked you, do you know what RNA is? And you said
Yes. Yes, I do. It's ribonucleic acid.
and I responded
And it's
to you.
Yeah, but I'm saying like
DNA is deoxyribonucleic acid, and it can be the RNA can be changed back.
Yeah.
It's kind of like
It's an important part of a respectful conversation.
It's always at your eye level. It's always at your eye level.
Here's the best part about it.
That's awesome. Where did you get this? Oh, this is I had this. So here, I want to sign over here.
She doesn't want these kids' brains being poisoned by a drag queen, but she sets this shit up. Like you just want the opportunity to poison the mind.
So a drag
You
queen
don't wanna
is
do that.
the drag queen
You don't want
thing
anyone else to poison
is really good, but evidence on a flat Earth is not good.
It's not evidence.
How do you feel about the drag queen?
It's all debunked science.
I think it's entertainment and it's for adults.
Adults? Why?
They're debunked theories not based on any science.
That's not real science.
But it's not.
You don't even want to look at it, so why are you here? You just mock
I
it.
read it all. It's standing right in front of you.
Flat Earth. I did not think anything about flat Earth.
Because it's not that strong.
Wait. Gravity's holding this building down, but it's not pulling my hand down.
You don't believe in gravity now?
It's a theory. No one believes in it.
Well,
That's
I think
right.
that it's proven. I do think that's proven.
Where is gravity? How come it's not pulling my hand down?
Gravity is actually a force that we can't see.
Gravity's pretty weak right now.
Things fall. There's
It's
a
not that
rate of
strong.
fall.
You can go against the. You can go
But
against gravity, but that's the
either we're being pulled down or we're being pushed down. We are being pushed down because we have levitation. That's proven.
There's no levitation. I don't believe that.
Diamagnetism. We are living inside a torus field, and there's free-flowing electricity up there. It works like a car speaker, and diamagnetism is pushing us down. Everything has a magnetic force.
Are you going to talk about that inside there? Or what are you going to talk about?
Yeah, I'm just doing this in there. It's about 20 after.
Are you going in like next or?
Yeah.
Okay.
And what's your name?
Marilyn? Marilyn Spirit Level. That's my channel. That's my channel.
Okay. I don't know if you changed your name.
Hey, if Annie Chris can change her name, I can say mine's Marilyn Spirit Level.
Your name no matter what the
Yeah. Well, the thing is, I find it interesting that flat Earth enthusiasts or whatever you guys go by, aren't necessarily politically aligned with any movement. You know what I mean?
No, we're all about the science. That's
Yeah.
it. That's it.
It actually is more science-based than actual globe. I
Yes.
haven't heard any science from a globe.
Yes.
I just asked that gentleman over here. He
Well,
couldn't
he's
give me
a
anything.
teacher.
That's right. You cannot prove a globe.
I think
Scientific proof. I got nothing.
I believe in the theory of gravity. I don't know. I mean, like, you guys pretty.
Yeah, but that's because you never looked at anything else.
Well, I did it.
So
you're right.
compare. So compare the two.
I do think that there's a science. No, I know. I think there's a consensus among people that do this
All right.
more than I do.
So if
I
100
don't- which is not a logical argument, you're right.
people jump off a cliff, are you going to do it?
No. I think that's like what I'm doing right here is actually making the what's it called argument? It's an argument that from a
Straw man?
Okay, but that's not a logical argument unless, of course, you're arguing that that's one piece of the puzzle. I think one piece of the puzzle is that people that study gravity, the Earth, et cetera,
How will you
believe
test
in
diamagnetism?
around Earth.
There are some there's some videos on it, and it is a provable force. And that's just what I think it is because of those things I've seen. Now, we are doing some experiments, and there is anti-gravity, so-called, and that comes from, reverse polarization. We do have that.
I do think it's like
So
it's very.
the government knows a whole lot more than they're telling us. They do not tell us anything. They have such technology, it would just blow our minds. But they're not going to tell us because they want to fake an alien invasion. That's how they want to control us. They want that one world order, so they're going to unite the whole world under an alien invasion. That's what they're going to do. That's what we think. Yeah, because wow, that's really cool. But yeah, but see, I don't want to be controlled like that. I don't want to be kept in fear, and I want to have a free life, and that's not good.
I think this point would you say it generates it's getting bigger, right? I think it's more people.
It's ancient.
Minority.
The globe is the thing that they injected.
You're right about that.
And when they took that picture out of from outer space, out of the porthole, and showed us around Earth, the whole world went, uh-oh. And then they started getting the Bible. Uh-oh.
Yours is flat. I knew it.
Sorry, thank you.
If it wasn't flat, it wouldn't have fallen.
If I go in the building, it'll be good.
Yeah. You might want to.
I'm going to go do that, too.
I'll hold this one.
I think it's all,
Yeah, but it comes apart. Oh, no.
yeah.
It's wasted.
Oh,
You
here.
gotta fold it. Oh, there you go.
Thank you. Thank you.
Hey.
You're helpful.
Flat's a flat. Oh, thank you. And it's so nice to see.
I'm going to see if they'll take me in now.
Yeah, here you go.
Oops. Tom, can you roll up that rug or something? Oh, I'm good, thanks.
You're good.
Yeah.
What's God doing?
I'm good, I don't need help.
Oh, sorry. This is the library.
Oh, that's right, that's right. Yes, dear.
I'm going to hit the restroom, and if you need anything else,
Okay.
let me know.
Thank you, dear.
They're all going home.
It's just us.
It's the next one.
Yeah, I'm going to go through the whole thing, and then I'll just...
I gotta go, but I can't stick around, unfortunately. I got friends coming over. But
It won't take but 10 minutes.
yeah. I got guests coming by. See if they go over there.
So I will come wherever you are, and I will do a presentation
Yeah.
for a group. You know, if you have a party outside in the summer or, you know, whatever, I will do a presentation for anybody anytime.
Okay. Well, I'll check out your YouTube channel. I'm gonna head out, but nice meeting you.
Okay.
Yeah, take
nice
care now.
to meet you too. So that's a curvature formula. Why don't you have a seat?
Sure.
And look at this, and then, you know, try to figure out. You should.
Ed, I'm Ryan. Nice to meet you, Ed. You know, exactly. This has to be more simple.
You can have one.
Come on, buddy. Come on. Nice to meet you. I like you. Come on. Come on. Is there like a presentation going on?
Yes. I'm going to give you a presentation. Would you like to join us? Okay. This is about the flat Earth. And we're going to tell you what it is, so you know how to make a good decision about what you believe. You see, I find it very interesting. Mm-hmm. So, is everything okay?
Yeah, I
Okay.
just want to make sure everything's okay with you.
Everything's good. Okay, thank you. So, welcome everybody. I guess we're okay with the doors open. But my name is Marilyn Teed. I have a YouTube channel called Marilyn Spirit Level. Okay, and I am recording. It's a public place. So I'm going to go through this quickly, and you can stop if you have a quick question. But if it relates to something that I haven't gotten to yet, then you might want to wait to the end. And then we'll go through it again and ask questions about anything I covered. Marilyn Spirit Level. I have 2 channels, so I have almost 2,000 subscribers. One is Spirit Level Gmail. That's how I upload my videos. Okay, so this is the flat Earth map. North Pole's in the center. Antarctica goes all the way around the outside edge. And you will notice that all these organizations, like the World Health and the United Nations, they all use a flat Earth map. But they leave off Antarctica. They don't put it on there. And I think they don't want you to know that it actually does go around the outside edge. You may come sit down.
I was just watching from here.
So, if there is a globe, okay, let me put these on. If there is a globe, then there has to be curve. It has to curve, right? And if there is curve, there has to be a formula, mathematical formula. Now, this is based on an equator, which we both agree, flat earthers and globers agree that the equator is 24,901 miles. Okay, so based on that, we have a curvature formula. 8 inches times the miles squared, and that gives you parabola, which is the curve. So here we have a picture of, and if you look closely, probably from where you're sitting you can't see it, but if you look closely, there's Chicago, and this is across Lake Michigan. And I usually say it's 60 miles, but there's between 50 and 60 miles, depending on who you talk to. That should be hidden under 1,700 feet. No, I'm sorry. That just escaped me. 1,700 feet. That's a 170-story building. So 1,700. If you go about 10 feet per story, 1,700. This one, yeah, that's how it works out. So that should all be hidden. Chicago should not be seen from across Lake Michigan, but we can see it. So where's the curvature? And
So you take into account like the raising and lowering of elevation?
well, this is a lake, Lake Michigan. So you really don't have tides.
Sure, no, but the land on the sides is a higher elevation than the lake itself.
Okay,
Like
well
how
he's
high was the vantage point?
That's why it's
he's down on the shore, right next to the shore.
Sure, still
Now
higher.
I'll tell you. Now I was just going to say that.
Chicago's higher.
I was just going to say that Rob Skiba got in a speedboat and he went from this side because they were saying, oh, well, that's due to refraction. And this was on a weatherman's channel, and he said it's a superior mirage. But a superior mirage does it in reverse, okay, if there's actually that happening. And we have seen superior mirages in, there's a video called The Red Boat. It's a freight liner that goes out of the bay, and when we zoom in on it, you can't see it anymore, but when you zoom in on it, you can see the top of the boat reflecting the bottom. So that's
Chicago's on elevation.
okay, but it's still not 1,700 feet. See, this is what we're saying, is that there's no curvature of any value that you can really say, well, I mean, what happens? What happens? Does it just disappear? So he went in a boat and went all the way across, and there was no change in the refraction. There was none of that happening. When it got closer to Chicago, it got clearer. Yes, granted, it got clearer, but there was no change. There was no, you could see clearer, but it was still Chicago. So these are other pictures. If you look online, a lot of these, this is what, the Isle of Man or something? Oh, Genoa, Italy. 102 miles away. And there's a lot of those pictures that we are seeing. We're just seeing way too far. Way too far. We have these cameras now called the P1000. And it used to be a P900 a couple years ago. Now they upgraded to P1000. And we can zoom in 100 miles easy. And there we are seeing way too far.
Again,
I'm sorry.
sea level. The map only works at exactly sea level. The Earth is not exactly.
Well, you know what? You know what? I'm not going to take arguments. I will take questions. I'm giving a presentation.
Why aren't you accounting for sea level?
So this is when you have curvature. When you have curvature.
This is a bunch of bullshit.
You were taught this in school. So
Right, I was taught this in school. I was taught not this in school. I was taught
get
reality
going.
in school.
We're gonna get the.
was taught
We're gonna get
reality
the.
in
We're gonna
school.
get the.
This is-
We're gonna get you.
Bugger off.
Bugger off.
Yeah,
Bugger off.
I'm gonna go get Tom
This
if
is
you're
just
gonna do
spreading
this.
lies. Spreading lies is not good for society.
I'm gonna get. No, I'll get the library manager. Tom. He's annoying us.
That's an assumption on your part, isn't it?
This is your right to disagree. So there is curvature formula. Now, what I carry this whenever we go down to Ocean City. Been there 3 times this year, and the group goes down. So here's the formula, and this is how far we can see. And when you look out, the horizon is always at your eye level. So you put this up to your iris, you can see the horizon right at the end of that. Now, why do I say that? Because vanishing point, and with the horizon, when the 2 planes come together, it's a vanishing line. If you look at the water, you'll see, where's the water? Like here. It's water gives you a line. But if there's 4 planes coming together, like the railroad tracks, you know they continue, but the tracks each give you another point of perspective, so it goes to a vanishing point, okay? But when there's only the top and bottom, you get a vanishing line. So things vanish in there because your eyes cannot see past that point. There's other things that I've learned about called angular resolution, that you can't see something. See, like if I go like this, I can't read this writing on here, but if I go up, then I can read it because that's angular resolution. I can see it clearer when I'm at a different angle. And that also happens at a distance, okay? So you have to study perspective. When I first started looking into flat Earth 3 years ago, the first time I heard it, I thought, this is just nutty. Why would I wouldn't look into that. So I just dismissed it. And the second time I said, oh, here it is again. Oh, those poor delusional Christians. And I'm a Christian. So, I mean, like, the third time I said, all right, this is annoying me now. So I knew something. I knew if there was anything to it, it would have to have a working model. So I went looking for a working model, and I found one. And it, like, explained everything. And it made more sense. I'm there, oh no, I'm really in trouble now. So there were some things I didn't understand, and perspective was one of them. So I really studied perspective, and like 2 or 3 weeks, I really dove into it, and I said, how can I see that? What am I looking at? And this really explained it thoroughly. And I went to both sides of the argument. I wanted to make sure, because I wasn't going to go out and teach something I didn't know. So, perspective. Model. Oh, model. Okay, so the model. I also saw a movie called The Principle, which is about a geocentric model, but it was the sphere Earth. But everything went around the sphere, where the Earth, the geo, was the center of the model. It doesn't move. Okay, and everything goes around it. So I knew that model, and then just making it flat was the next step. And that made more sense. So, although I do think there's a dome above us, which could account for other theories like hollow Earth, and I'm not sure, I didn't really study that really closely, but that could be what they're thinking. We don't have it all figured out. I'm telling you, we don't have it all figured out. We are looking at these things. We're investigating. We are certainly not being told truth in school. This is what we learn in school. We get the moving sun, we get planets spiraling around, orbiting, and the sun is moving, so these planets are like trying to keep up with it, right? And then it's all in the Milky Way, and that's spiraling and spinning. So it all adds up to about 2 million miles an hour, all these movements. So that's what they teach us in school. But look what we get in reality. That's reality. Star trails. You put your camera on Polaris and you leave the aperture open, That's what you get. So how can you have that from that? That makes a whole lot more sense. That is, the Earth is stationary, and the stars they're fixed in the dome, and the dome is turning. The stars, they never change their relative positions. Okay, the planets do have some retrograde, but the stars are fixed. You always see the Big Dipper, but it's when a different season, it's over here. Different season, it's over here. And then a season, because it moves. But the Big Dipper's here, Little Dipper's always here. You know how to find it by following the two stars. So that's how you get that. So when you have the stars that are always in the same position, well, that should tell you something. I mean, how can they always be fixed?
I have a question.
Okay.
How do you account for the shift of the North Star over the last?
Well, I'm going to say that's what we were told.
Well,
And
but
I know,
people used that for navigation for thousands of years.
and that's what we're told.
It had.
And I
But
don't,
there's records for thousands of years.
I don't
People
go
knew
by,
that.
okay, you can say all those things, but I'm not going by that. Because if I can't prove it to myself, I'm going to say, I don't know, or that's what you're told. And that's what I'm going to tell you, because I can't prove it.
But so what you're saying then is thousands of years ago, people conspired to do this and have over the years logged the shift in the stars.
Okay,
But
all right.
that's been to keep us.
I understand what you're saying, and I'm going to tell you this. The guy who wins the war gets to write the history books.
Right, but we have those records. They exist. And they're like.
And they can
journals
write
from people.
the history books. And you tell me, how does that change? Okay, they say there's a magnetic north and a true north. Okay, so I haven't really researched that thoroughly. Right now, I am taking compass readings seasonally, and I've just yesterday got 3 people in Australia to do this. We're all going to do this together, taking compass readings. Okay, sunrise, sunset. I had a woman in South Africa. She's not really up on this kind of stuff, but she did her best, and she gave me some good data. So, we have to know these things ourselves. So when you say something, oh, well, look, we have all these, okay, all right, so that's something to think about, but I'm not going to base my life on it. I am not going to do that. I'm not going to say, well...
But that's a simple observation that can be viewed.
Okay, but still, what does it have to do with the surface of the Earth? Not much.
Well, it has to do with Earth's movement through space around the sun and through the Milky Way. The shifting of stars, because our relative location to them has changed.
No.
Because the stars are now in a different
I disagree with that totally. And I'm going to say that they won the war, they own the publishing houses, and they are writing the books. That's what I'm telling you.
I'm not saying
We got to move on.
Published, you can go to
We got to move on.
and find journals.
I'm moving on. That's an argument. You want to ask a question? That's okay. An argument, we're not going to do that.
Okay, you didn't actually answer the question. You avoided it.
I'm going to tell you. I'm not going to answer it. You got my answer.
Okay.
So here we have crepuscular rays. Now with this proves, I think it proves that the sun is not 93 million miles away. Okay? Look, you have the rays coming down at angles and even going up out of this cloud at an angle. So that means that the sun has got to be somewhere in there. Now, it could be farther back, but I have seen these crepuscular rays shining on water beneath. So it's like right down, and it's a circle. It's not like an elongated oblong reflection. So it is. It's not. It's directly. If it's a circle, it's directly above. Okay. If it's elongated, then it's on an angle. So I have seen these pictures where these crepuscular rays are giving us circles. So it's like right there. Some people will say, well, it's way off in the distance, but I disagree with that. So now, the crepuscular rays themselves, if it is shining through the atmosphere, okay, if the sun is shining through an atmosphere, it's the leading edge that determines the angle and the refraction. So if it's shining through the atmosphere like this, they would go inward. They would hit that dome or hit the atmosphere and angle inwards. Like a magnifying glass. That is the leading edge. It's not the tracing edge that determines the angle. It's the leading edge. So that totally refutes when somebody says, oh, well, it's, hitting the atmosphere and that's what's making them on an angle. No, it's not that. So, right here, here's a picture of a circle. That means that sun is like right above that. So, water. Here we have, no matter what's underneath that water, the surface is always flat. Even if it's a globe, the surface is over, the curve or whatever, then the surface is always flat. It never does this. Never, never, never. So we know the surface of water, undisturbed water. People say, what do I get? And I've been doing this all year. I've met thousands of people and had thousands of discussions about this. And they'll say, oh, well, what about the tides and all this stuff? Like, you can't really, sea level's not really sea level. Okay, so let's take a mean average or something. Let's, just be logical. Undisturbed water is always level. It's like glass at places. There's Lake Baikal, and I'll bring that up again, in Siberia, 400 miles of flat. So how do we know a flat surface? This is, here, let me get the card. Okay.
What are you using to measure the flatness of that water? Are you going by eye, or are you using instrument?
Okay, when you're going to be talking about flatness, you're going to give me the grace of a tolerance. Okay? If you're going to say, well, it's off by 6 inches, I'm going to get annoyed and not even answer your question. So you're going to give me a tolerance, because we live in a moving world. Things move. The water does move. It has waves. Yeah, okay. So
Sure, but like one continent to the other.
one continent, sea level is sea level all over the world. Sea level is sea level. I had a woman, she said she had a master's degree in physics at Jim Thorpe. It's on my video. And she said, oh, well, the Panama Canal goes up. I'm there, what? She said, yeah, the Pacific Ocean is higher than the Atlantic Ocean. I'm there, no, it's not. I said, it goes back down again. I mean, she didn't even know the Panama Canal was up to a lake, across a lake, and down again. So, I mean, sea level is sea level everywhere on Earth. It's the same. Go ahead.
I think to the water perspective, I think you're trying to just describe, correct me if I'm wrong, just the chemical makeup of water. So I like to use a water bottle. So, say I have the water
level.
Here. So right now, if you put water in a bathtub or a water bottle, it's going to stay level, right? If I put it down here, the water is naturally going to be level. It's not curved. It's not concave. If I put it in a water bottle, if I leave it there, the water will also stay level. Like the bottle itself is curved. Like this bottle, actually,
right.
Like that picture up there. But the water itself on the top of the water, not the bottom of the water, but the top of the water is level.
Yeah.
So that's where we get our sea level.
Yeah.
So measuring the distance of the water is different.
But that's not my question. My question is, how are you measuring how level the surface is? Like, what instrument are you using to measure? Are you just going by eyeballing it?
I think,
because the thing is, that would be level to the naked eye, but technically, at the scale of the curvature.
And that's what I said to you. If you're going to be nitpicking, I can't address that because you're looking for something.
I'm asking what.
Well, here we have a level, the spirit level, and that's how I got my name, and that's what they used forever.
Sure, but I'm talking about the scale and size of the globe that is the Earth. That would be immeasurable and unnoticeable to the naked eye at such a small
All right,
unit.
how do we know over here, like in England, it's the same. All right, how about a gyroscope? Is there anything that will satisfy you? We have gyroscopes in airplanes.
I'm asking a genuine question. Which
All right,
is if you are,
gyroscopes in airplanes. When they start off at the runway, they calibrate that to the runway. Okay, they're flat and level. They take off and they fly across over to England. and they come down, and it's still level. And it was level all the time they were flying.
Well, it was level to the surface of the Earth that was underneath.
So you're saying that there's like a tether from the center of the Earth, and that tether is like allowing it to go like this, really?
Gravity, yes. That's the
So you're
force that
saying that
pulls us to
it's
the
just
front.
big.
Yeah, the Earth.
Yeah, so
Your argument or presentation is that would it still be level, but it's relative to the
Well, my point.
curvature of the globe?
Correct. Yes. Because the whole point of, I'm asking how you know that water is completely flat. Because you're saying it's flat
Yeah.
at all points. My name is Ken.
Ken, I'm Ryan. Do you mind if I just...
Go ahead.
I just
Sure.
want to try to answer it, and then we can go on, because I think you're
Yeah,
getting to the airplane.
because
thing.
I was out there on the sidewalk, and I'm like a little frazzled. Go
No,
ahead.
that's fine. No, that's fine. Because I think, and maybe the ancients did this, but we always found things on the earth to kind of measure things, right? Like she's saying the level, like what makes up the components of the level that proves that it's level, right? How do we know we can rely on that kind of thing? Is that what you're asking?
No, I'm talking about how are you measuring microscopic differences in...
I'm not.
bathtub.
I'm not, and I'm not going to.
But that would be the curvature that exists
No,
in a tub.
the curvature is not microscopic. The curvature is 8 inches times a mile squared. And over 60 miles, that's 1,700 feet. That's a 170-story building. That's not microscopic. That's like really visual. Like, you can't deny it.
But
That's why I say about
keep
nitpicking.
going
You know
back.
what a nit is? I'm losing my patience.
Yeah, maybe perspective from above the.
So just last thing on that, the ocean, like water being level. So we said we took off here and we came to the other shore. If we put a post like 90 degrees to the water level here on the shore, or whatever, and then here on the shore, and then shot a line straight up from each of those,
They would not intersect.
what star would what star in the sky would they?
Well, that's hard because the stars are always moving.
Well, in the
Okay,
free-
Aries failure. If you want to experiment on determining if the stars or the Earth is moving, Aries failure.
But would those two lines be like straight
Parallel.
up? Would they be pointing
They
forward?
parallel.
They parallel.
Parallel. And we're doing experiments. We went down to Temple University in Philadelphia. And this guy said to me, oh, well, you know, the bridges, they're like a little farther away on the top than I'm there. Oh, really? I said, then you go get a cityscape like Manhattan. How long is Manhattan? A couple miles. Okay, so then you get it far enough away and you measure those buildings and see if one is farther away at the top than the other one at the other end. That would be your quest. And he said, yeah. So he went and was going to go do that. But they aren't tilted. They're all straight up from each other. They're all parallel. They are not tilting away. If there is something like the Golden Gate Bridge, it's like a couple inches wider at the top. Well, that has to do with the structure of the bridge. It's a suspension bridge. They need it to lean a little bit to help hold it or whatever for the suspension. But it's not because of curvature. We're doing a lot of stuff on the Lake Pontchartrain Bridge down in Louisiana. 24 miles that bridge is. And there's a guy called Sound Lee, he's a globe head, and I hope you don't mind me calling them that, but they're globers. And Jesse Kozwalski, he's also a globie, and they go down and, oh, look, you can't see across, and it's got to be curvature. And no. I said, give me all your data from your GPS coordinates for the whole length of the bridge. He would only give like a quarter mile. I said, I want all of those data coordinates. He won't give them. They're hiding something. They don't want to give it out.
Oh, but anyways.
So, this is one of my favorite pictures. Plane Ranger over in England. He sets up this little display and he has a 6-foot level. I said, well, I only got a 4-foot level, so you're much better. But I have made so many friends with this. This is wonderful all over the world. I don't know if I'm going to be speaking over in England or not. But look, the horizon just matches right up. It's so beautiful. It is so beautiful to know that we live on this created realm, this created earth. And I don't know really, I'm not going to say about who created it. It could have been an ancient civilization. It could have been the laws of nature. It could have been whatever. But I let everybody decide that for themselves. All I teach is the science part of it. So this is what Antarctica looks like, and that's the only thing we know. We are not allowed to go there and have free exploration. You can go there, pay thousands of dollars, and they will hold your hand and escort you to their fake South Pole, and they will tell you it's fake. It's not the real one.
How do you account for the man who recently walked across Antarctica?
That's what he told you. That's what I'm going to tell you. That you believe what you're told, and I don't. That's a big difference between us. I only go on what I know for myself. And when I
believe based on observation.
Okay, but you didn't go there, and you didn't do it, and you believed them, and I was the same place that you were 3 years ago. I believed what they told me. I believed that there's an outer space. I believed in the globe. I believed in evolution, even though I didn't want to. And when this came along, I'm there, oh, that makes so much more sense, thank God. I mean, that's the only time I mention God. Okay, so...
We don't mind.
Thank you. So anyway, but so many people do. Foucault pendulum, that was brought up today. I went down to, I went on my daughter's 6th grade field trip down to Natural Science in Philadelphia. Is that the name of that? They have a Foucault pendulum in their stairwell. And I went, no. Franklin Institute? Okay, thank you. I said, why isn't that thing moving? It was dead straight, not moving. I mean, why isn't that thing moving? That is so odd. And I didn't think anything of it. Now I know why. Because in order for a Foucault pendulum to work, it's got to be manned. They have to put it in motion. They have to monitor it. Those things were all made up and put all the way around the earth, all over the earth, to convince us, to make us believe.
I don't understand why. Believe what?
If the earth was truly spinning, it would go on its own. It would go on its own. If it was truly moving, it would go on its own.
Just like start moving and back and forth, or like
That the motion of the
Magnetized?
I'm sorry?
Is it magnetized? Why?
No, it's just like a plumb bob. It's a plumb bob, a pendulum. It just hangs by itself with a point on the bottom. And then they put these little dominoes around, and then, oh, look, it's spinning. It knocked this domino. Now it's over here knocking that one and knocking that one.
what's it supposed to do on its own? It's supposed to start moving on its own?
It would move on its own if the earth was moving. They were all put around the earth to say that the earth is spinning. That's the whole point of the Foucault pendulum. It says the earth is spinning, but it would move on its own if it was really being affected by the movement of the earth, and it's not.
Why would it move on its own? I don't understand.
I don't think that's supposed to demonstrate it.
If the earth was moving, it would move on its own. It is not moving on its own. Henceforth, the earth is not moving.
So I think what she's trying to say is that way back when everybody believed the earth was flat, how do we prove that it was actually a globe that spun at 1,000 miles an hour? So there's two things. There's curvature, which she's trying to show with the lake and the level. And then there's how do you prove that the earth is moving at 1,000, like your measurement test? How do we prove how high something is off the water? Well, how do we prove something's moving at 1,000 miles an hour? Right? I mean, I can measure...
Oh, you gave away the answer.
What?
If the equator's 24,901, how fast is the earth spinning? In a 24-hour day, 24,000, it moves 1,000 miles an hour at the equator. Up here where we are, it's about 700 miles an hour. We're supposed to be spinning, and we have no effects of that.
Well, if you drive in a car that's moving,
Yeah, go ahead.
that is not accelerating, that is at a constant speed, you don't really feel any effect from that.
Right.
So, like, you feel the effect of acceleration, but you don't feel the effect of relative speed. If you're moving at the same speed as everything around you, you wouldn't be, like,
Right.
pushed back.
Right.
I've heard that before.
But this,
Okay, so in a car,
Right, in a motorcycle you feel it because there's wind resistance against you. You're
so
moving through
so you're saying there's a dome.
moving. I'm sorry?
So you're saying there's a dome.
No. Why
But
would I
you,
pretend-
because in a car, there's a physical barrier. In a motorcycle, there's no physical barrier.
Right.
If the Earth is really spinning around the sun at 66,000 miles an hour, there's no physical barrier. You think we'd feel that?
Well, you're assuming that space then has...
I'm not assuming anything.
Well, no, you are, because you can't actually physically interact with it. you're assuming that space then has mass and friction that would be pulling back on the atmosphere of the Earth. But if there's nothing in space, if space is actually emptiness, there's nothing that would actually be resisting against it.
Okay. So the next point is, how does the ISS move around if there's nothing to thrust off of? How do all those things move?
Yeah.
You cannot have thrust in space, in a vacuum of space.
Oh, you absolutely can.
You cannot.
Well, the thrust is two things.
You know what?
pushing
Here we
across.
go, argument. And you're a globe argument, and I don't want to argue.
Well, no, I asked
I'm
a question.
telling you something different than what you've learned.
sentence.
No, because if you want to get your own banners, you can do that. But I'm
Well,
telling
you
you,
opened it to question.
I'm telling
I proposed
you
a question to you and you didn't
that
answer it.
that
And then
I-
when I had a counter to what you said, which was deflecting from what I had asked, you then cut me off with something completely unrelated.
because
I'm here to
because
listen to you,
because
but
I'm not going to
also
argue
challenge
with you. I'm giving. You're not going to. This, you want to have an argument, and I don't want to argue.
I don't
I've
have-
heard all those arguments
But
many
I'm
times.
asking a question. If you're trying to convince me,
I'm not trying to convince you. That's where you're wrong.
But that's exactly why.
No,
you're
no,
here.
and I tell
You're here to present
people
information
all
and
the
I have-
time, I'm not here to convince you. I am only here to present evidence.
But I
And
have-
you
I
can
have-
go
I'm
home
disproving.
and you can see all the evidence right there and you can discuss it with yourself.